So, we will start now with the softer skill. That is, so far we have seen most of the scientific part, about biorefinery, what is bioeconomy, circular blue bioeconomy, and then processing technologies, ingredients and products. Now, we are towards the end of it, and that is all to do with to understand what is research, what is innovation, what is business model, how do you engage with different stakeholders. So, main focus will be to differentiate what is research, innovation, and how do we, why do we do research, and how do we engage or benefit to the community. Yeah. So, what is the difference between research, innovation versus invention? Invention is to find a new thing. You find something new, that is an invention. But innovation is slightly different. So, once you have a knowledge and you use that knowledge to convert into revenue, that should be innovation. That means scientific knowledge is there, yeah, and generating a knowledge can be a invention of creating a new space of knowledge, and when you convert that one into revenue, that will be known as innovation. Whereas revenue is used to create a knowledge, that will be research. Yeah. Institutions are there, they get money, and you pay fee to generate, to get the knowledge. Yeah. So, you use money to generate knowledge. Yeah. In what form? How knowledge is generated? That is one way of seeing it as a research. Yeah. You need money to carry out the research, so that you create a new scientific knowledge. When the same knowledge is used to create revenue, that will be considered as innovation. Is that clear? So, you need a money to do the research project. Research project is there, people are employed on it, people they do PhD and they get stipend, salary. So, what is their purpose? To create a knowledge. Yeah. Once you create a knowledge, you develop a technology, you develop a process, and that particular process is again used to generate income. That is the purpose of it. Yeah. So, conversion ratio cannot be 100%. Yeah. So, revenue to knowledge is X percentage, but knowledge to revenue can be quadruple, yeah, or 100 times of X. Yeah. So, that is the way we have to see research and innovation, and difference between invention and innovation. So, invention, finding something new, finding how finding telephonic communication was invention, and all those things what is coming on now is all innovations. Yeah. The chips, or including that system. So, that must be very, very clear what is research, using revenue to create a knowledge in form of research, project, purchasing a book, generating the knowledge. So, that is all one side, and when you use the very same knowledge to create a revenue, that means you got the knowledge, you made a system and you start a new business, that is startup. Yeah. That will be innovation. Is it clear? So, that is pretty much straightforward. So, what should be the research and what should be the innovation activity? What does it mean? What are different types of research? Research are normally classified into 3 different categories. Yeah. Basic, applied and commercial. Majority of you in food science is in applied research. Yeah. Basic research will be how butterfly flies, how plant grows, yeah, what happens to the plant, how plant converts CO2 and water into glucose. That is all basic research. Yeah. Understanding, that is fundamental aspect, and when you apply that particular knowledge, that becomes applied research, and if that particular applied research is done to develop a big processes, that is advancing the technology readiness level, that becomes commercial research. Yeah. Investigating the shelf life of a biscuit company's product, yeah, that is exactly a commercial shape of research. Yeah. Within that one is exploratory, yeah. What else? Experimental, that means you carry out experiment, and other one can be investigation, yeah. So, can you give the mic? Yeah, here, first one row. Sorry.
Sir, any other research just like qualitative, quantitative, and fundamental or exploratory you were already mentioned.
Which extra?
Sir, you were already mentioned exploratory.
Fundamental research.
Sir, descriptive research.
Qualitative, quantitative,
descriptive.
Yeah, descriptive, and all these type of stuff. For example, carrying out the survey.
Yes.
Other day when you received a questionnaire survey, that was basically qualitative, yeah. Quantification, these are again further classification of the research activities. So here focus was mainly on the research what are related to innovation activities. So if you will see what are your motivates for answering this way, right? That means I do this research for publication, I do this research to solve this problem, yeah. So what is your exact motivation to answer that, whether you are doing basic research, applied research, or a commercial research, yeah. And again, what are the advantages of applied and commercial research beyond fulfilling the funding requirement? Suppose you get a funding, yeah, you as a PI or somebody is running a project to develop your project, for example, developing a treatment strategy for wastewater by X, Y, and Z technology, yeah. Will it be applied research, or will it be a commercial research, or will it be a basic research? So it will be basically applied research, yeah. Wastewater is there, and then you are trying to use technology, for example, microalgae, which can quench some of those inorganic nutrient into organic form. So you are trying to use that one, so that becomes applied research. When you make a process, that means A species, B, sorry, I am very bad in using this one, A species, B technology, C end product, yeah. You develop the process, yeah, taking this much amount of water, this should be the flow rate, this is the species to be grown for this many days, and then this is the technology to use, and this is the product what you will obtain, yeah. This all becomes process, and if some company is interested in that one, or you start your own business, that becomes commercial, yeah. That means scaling that one up at a commercial scale becomes commercial research, right. Now, what is the advantages or disadvantages of different types of research? So the moment you go into further different type of categories, fundamental research, qualitative research, quantitative, descriptive analysis, and all those things are there, yeah. Some research is carried out only to get the information, so that you can create a policy, like surveys, yeah. So all those information, you fill a lot of surveys every time it comes on email, like other day you got it with the QR code, yeah. That was mainly to see what is your perception and what you think what is required to be done, yeah. I'll run through those answers maybe today at some point, or maybe in evening today, yeah. So that was quite interesting to see whatever we covered, pretty much it is within that particular line. Some places, some differences were there, so that was only because there was no all of the above choices were given, yeah. Now in that case, so what is the advantage of basic research?
Sir, it is the pure research, it on basic on the mathematical. So this is the basic, and when we applied that particular, just like microalgae we can grow in wastewater, when we applied and do the practical, it's called the applied research.
Okay. So basically basic research is again, well, mathematical is one way of putting it, basic is to know how things happen, yeah.
What is happening and how it is happened.
So I'll give a common example of the gravity, yeah. When we develop equation in your, when you said about mathematics, we put a gravity equation, yeah, that becomes a basic research, yeah. When you apply that gravitational force to transfer product from A to B, that becomes applied research, yeah. and then you make an engine, that is, this is the principle, you make an engine or rocket engine, and then it is used to test different ways that becomes commercial. Yeah. So, that is the way you have to be very sure what we are doing. So, in majority of the cases commercial research is for monetary gains, yeah, that is generating revenue, yeah. Applied innovation side of it, yeah, right, and basic as a research, yeah, innovative research, basic research, fundamental research, right. So, this is for creating the knowledge, yeah, innovation and revenue generation, right. So, that is the way link between research and innovation. So, what way we should carry out the research? What should be the priority? Like for whom we should do the research? Just to be employed? Why should we do research? So, before that, if you go in ecosystem model, right, this is money, idea, that is technology, what is called technology readiness level, concept developed, yeah, oh, this works like this, why do not we make this, that becomes concept, then you prove that concept, yeah. I will take your example of your osmotic dehydration, yeah. It is known that osmotic dehydration draws out the water, yeah. You use osmotic dehydration for your cheese or paneer, yeah. So, you developed a concept, yeah, and then you try to prove it that it is better, yeah, and then you validate it, then you validate in relevant environment, that is at commercial setting, because what works in a lab may not work outside, yeah. Then you demonstrate in relevant environment, then operational environment, that means at real factory setting, and then you configure the system what all is required, because what is done in lab in small centrifuge cannot be done at large scale centrifugation. Then you have to have a different system, and then you launch it, yeah. So, that is the sequence of any idea or any technology. So, majority of the idea they start from here, they end up here, yeah, or you can take this as a most comfortable zone, yeah. Advancing any TRL from here to here, it takes ages to get it done. That means setting up machine at nuts and bolts at this point, yeah. So, if you are using an ultrasonic system for extraction, we think next day it will be having a commercial one, right. So, all those things at this point takes lot of time and money and investment, yeah. So, that is why if you would have been part of different organization, you would have seen that some people they got industry project. Oh, I got 10 million euros industry project. What is to be done? How do we make paneer? Yeah. Oh, it is very simple. It is simple if you do it in a lab. The moment you scale it up, the number of different challenges are there, and to operate it at particular environment. Now, this is the story with public funded research. Yeah. Majority of the public funded, whether it is a university, institutions or research organizations, all those type of research, PhDs project, postdoctoral project, all those fellowships, these all are pre-competitive research, that is some with the fundamental research max to max at this level, yeah. Applied, majority of the research what I heard from some of you doing is falling here, yeah. Nuclear physics, establishing the equation of nuclear fission. There is another GIAN course going on, you would have seen the board about stars and all. So, those all are coming in this particular space, yeah. Second part is industry funding. Industry is not much interested in basic research, yeah. Their main focus is what is the technology you have, what is the process you have, how I can make money out of it. That is their problem, yeah, or that is what they want to establish, yeah. You found a new ingredient which is having a better shelf life, or you got a new protein compared to dairy protein, and then they want to get that particular process developed to get competitive R&D, yeah. So, every multinational, every industry is having some bit of research department, yeah, and if you will see their research department is not as broad as what you guys do, yeah, or institutions they do. Because suppose it's a dairy company making cheese, then they only focus on dairy, they won't go on working on oats, another one. Yeah. So, that is, and where most of the institution they fall, or where my own organization falls in between. Okay. What does it mean? So, there is always a push and pull, yeah, right, whether it is a public research performers or businesses, yeah, all push is there. Oh, what is the purpose of your research? You spend so much of money, is there any technology produced, yeah, isn't it? And same way industry, government or universities, they ask industry to fund more fundamental research, yeah. So, this is all push and pull happens. So, where our own organization falls in to bridge this particular gap. So, in this is what Chagas comes in, where we have to fill up both the gaps between applied as well as fundamental research and a commercial research. So, the main mission and vision of this organization is to support Irish agri-food sector through science-based innovation. Yeah. So, in order to bridge this gap, has to some research. So, there is always a push and pull effect. Yeah. Now, in your opinion, what should be the priority? Fundamental research or commercial research? I am not putting an applied in between. Whether we should focus more on fundamental research or we should focus more on commercial research? Fundamental. So, that means all the public sector money should be used to know how microalgae grows or how butterfly flies and how different types of technologies work. Yeah. So, it has to be the cocktail of both. If you remember, sometimes fundamental research is required to get the commercial answer. Yeah. But you need to have a commercial answer to generate that revenue which can be used to create knowledge. Yeah. That is the way it works. You have a knowledge, you innovate, business starts, business makes money, business pays tax to the government, and part of that tax is used in educational institutions, all these lights, buildings and everything. Yeah. So, whatever fee is charged, that is much more expensive than who bears those costs. Universities are not a business model who is making a profit, lot of money comes from government, where government gets money from taxpayers, or tax comes from commercial businesses. Yeah. So, this is the way the model works. So, best balance between should be there between fundamental, business, commercial research and applied research. So, it is often believed that basic research always yield commercial research, but have you noticed other way around? Some research is done, innovation is done, innovative activities or applied research is carried out, and that leads to fundamental questions. When you carry out the experiment, you see why it is happening, that why factor gives you the fundamental side of it, right. So, that is what is important, different types of research that generates how or what should be innovation model or a business model, right. Now, who should be at the center point or who should be the priority for the research? Like when we do research, what should be the priority for what? You pick any particular topic, you are working on cheese, you are going to work on wastewater, somebody is working on alternative protein, somebody is working on something. Who picks that? What is the driver? Somebody is working on packaging material, somebody working different one, everybody thinks their area is good, yeah. But in some cases others area, research area is good, mine one is boring. When you start, everything looks good, as time progresses you think it is just ordinary one. Yeah. So, what do you think, what makes the priority? I know you all are employed on some sort of project or some works are going carried out. Yeah. Now, first and foremost, most important element there is consumer first. Yeah. Consumer or your stakeholder or end user. Consumer here is not the person who is consuming it. Yeah. So, consumer, customer, yeah, take it in the same way. Now, what are the customer? Wholesale importer, business to business, retailer, food service operators and a consumer. Just take exactly as a food one. Yeah. So, first you need to know what customers or consumers they want. Yeah. Right. Then they want, suppose, value, sustainable, premium, natural, functional products, safe, nutritious, innovative, trusted, authentic food. And then that decides what should be the priority. Yeah. That is why before any new product is launched, lot of companies they carry out massive surveys, yeah, to know what people are thinking about it, yeah, and what is their opinion based on they launch a new product, yeah. Or some cases they want to launch a product, but they want to influence the consumer choices, then those things are created, yeah. So that is why it is important whatever you are doing, where it will be used. You make it the technology. Where it will be used, blank. You should have clear answer for what purpose it can be used. Yeah. Oh, only these type of people can use it. Yes, because that was the target. Gluten free product only for gluten celiac patient. Yeah. But unfortunately, it is gluten free. People go and buy it like a cholesterol free. Yeah. You know, it's gluten free is only for celiac patient, and then accordingly you have a target consumer. So, consumer they drive policies, yeah. They say we want to have alternative to meat. So, what way to do? Alternative protein, and that is the way type of research or applied problem or problems are put forward and research projects are formulated. So, what we need there? We need, that is, who is the stakeholder here? Customer stroke consumer, yeah, right, A. And consumer for certain product, for example, if you take seafood itself, fish protein is an ingredient, and that ingredient is taken by another company, so that company becomes the consumer of that particular product, yeah. Then they make that particular fish protein, suppose they deodorize it to make a comparable like a dairy protein, so that becomes another consumer, and they are making into the beverage or making a product, that becomes another consumer plus customer. So, it is very important to know who are your stakeholders, yeah. That means who will benefit from your research and what type of message they should get, yeah. If suppose you are carrying out some research on omega 3 fatty acid or a fish oil or something, and consumers are there, like normal general public is there, and you start explaining this is the lipid structure, this is a double bond, this will do this. Is it useful for them? No. That is why some places when you were doing experiment, I said we will add 1% NaOH. 1% makes things easier for general public or industry to understand, rather than going for 0.1 molar, yeah, right. So, always to present the information in a simplest form, yeah, you do not make things complicated. We have enough of those complications. Now, another stakeholder comes in, institutional support, and this is just an Irish context. So, if you see, this is Chagas, our own organization, Board BIA, that is Irish Food Board, BIM, Board Ishmara, that is the way it is named, and Marine Institute, yeah. These are the institutes, and Enterprise Ireland comes into Department of Business, that is a different ministry, and all these are part of DAFM, that is Department of Agriculture, Food and Marine, that is a Ministry of Agriculture, Food and Marine. So, that is, instead of calling it as a ministry, all are known as the departments, yeah. So, that is the way the system works. So, again, how the policies are made, like government makes a policy that we have to, like for example, millets, yeah. What are how the policies are set? Policies are set bottoms up and top down approach. You see what is requirement at the ground, then at different levels, and then you concise together. Suppose you need a clean water, you need a good housing, you need a clean street, and then you just come up with a specific objective, and that policy is made, and those policies are imposed, well you can say imposed or said we have to work on these policies, and then based on that everything works out. It's bottom approach, bottoms up, all the information collected, based on rules are made, yeah, and these rules are now implemented. You know, if you follow some of those government procedures, when they create even the budget, they get information from every state, yeah. Every organization is asked to provide an input, what is the requirement, yeah. They all put in their requirement and they crystallize all the requirement, and based on that they develop a whole national budget, and then it is implemented accordingly, yeah. So, just remember what is the purpose, where we all fit in within that particular system, yeah. Now, previously what was happening, you have research and development, yeah. You carry out a research, you look for market, you look for new consumers, what industry needs, and then you realize impact. When we say impact, in terms of monetary value, yeah. You created a new product, encapsulated, take for example insulated caffeine, yeah, but there is no demand for that, then you start saying, oh, this is great, and then you look for market, consumer, and then instigate industry need, and then you look for economic impact. But now things has been changed, yeah. It has moved other way around. What market needs, what consumer needs, and what industry wants, yeah, that drives research, and then that is developed, and then to get the impact, yeah. It is other way around, rather than having research first then to develop it, yeah. Now the focus has more shifted towards development, so that you can have more and more innovation, more and more startup. You have seen that, like why focus is going on startup businesses, why government is putting a lot of money into it. So suppose consumer demand is, consumer is getting more and more obese, so you need a healthy diet, yeah. When you need a healthy diet, so research or developmental work should be focused only on that particular area, yeah, rather than making a product and then looking for the market, yeah. So this you will see, this is not only Europe, everywhere is the same, yeah. So you are inverting the old innovation paradigm. That means research, you carry out the research, you develop it, and then look for market, rather than market what they are demanding. That is again the push and pull agenda, yeah. So that is the way how the innovation things are shifting now. Now this is one of the video, because we in this big large project, one of our colleague or institutional partner, they are developing different types of product, from vegan type product, from fish or seafood. So this was one of those video was created on my request for you guys. So as I mentioned about different stakeholders, that is consumer, policy makers, government, and all those investment. So there are these this particular project which you may have, or you would have seen the website, that is Impress. How many of you have seen the website yet? So whenever you get a chance, just open it, you will find lot of information related to that. impress-he.eu, yeah. You will find all those things, because a lot of business companies are involved in it, making business models, and how do we, what is objective, and how what all will be performed, yeah. Within that context, when you talk about the stakeholders, all these industry, policy makers and all, so what is coming out of the project is not the publication or a patent, those things. Those are there, but also to see how we can change the government policy, or how we can add to the government policy, or a national or a European policy, right. Within this context, you will see what is the model and how this is being carried out in this context, yeah. Just hear her out.
Have you ever wondered how all of us can spark food innovation? At Impress, our industry-driven project, we are co-creating innovative food products from sustainable freshwater and marine ingredients through teamwork and collaboration. Imagine this: seaweed turned into vegan fish-like spreads, and freshwater underutilized fish turned into delicious, ready-to-eat fish spreads. If you are curious to see and interested to participate in creating these products that are better for you and the environment, dive with us into the world of co-creations. First, we analyzed the latest scientific research and looked on the products on the market. What's working? What's missing? This helped us set the stage for our exciting new creations. Next, we turned to the final experts, consumers. We asked over 1,000 people what is important to them when choosing spreads and about their willingness to choose new innovative combinations of ingredients such as algae or fish. This gave us useful input to create spreads the market would crave. Now we are ready to co-create. Our workshops brought together consumers, scientists, industry experts, and policymakers to mix ideas, expertise, and creativity. It's all about creating innovative spreads that combine science, market needs, and consumer preferences using sustainable and healthy ingredients. How we did it? We started with fun ice-breaking activities like word association and personification, helping participants feel relaxed and engaged. Then we introduced them to the unique ingredients they would be using. All of this sparked creativity for the spreads we were about to co-create together. What makes a spread stand out on the market? First, we analyzed the commercial spreads. What works? What does not meet consumers' expectations? And what could be improved? For this, we used role-playing to step into the shoes of scientists, food technologists, producers, retailers, marketing experts, and consumers. How can we create spreads that are tastier, healthier, and more market-friendly? With these insights in hand, we were ready to create something truly unique. What happened when creativity met collaboration? We jumped into ideation, using techniques like Lego series play to build new ideas for spreads. This hands-on approach helped us think outside the box and implement new thinking approaches. After ideation, it was time to get hands-on and real fun began. We rolled up our sleeves and started making spreads using traditional legumes, sustainable algae, and underutilized freshwater fish. These ingredients, which have nutritive potential and quality, were ready to transform the spread market, which continues to grow steadily. With every combination of ingredients, we brought something new to the table, crafting spreads that are as innovative as they are delicious. What spreads are the future food stars? Which ones have the most potential on the market? Our expert jury selected the best of the best. Now, these rising stars are in the hands of food technologists who will refine and perfect them to the next level of innovation and success. And so, the innovation journey continues. From concept to creation, we brought together the power of collaboration, innovation, and sustainability. These spreads are not just products. They are the future of food. Would you give them a try? Maybe one of these spreads could become your next favorite. So, what makes co-creative workshops so special? Participants combine both different perspectives and ingredients, exploring exciting new combinations. Hands-on activities foster creativity and boost ideas into promising food prototypes. Together, we turned underutilized resources into delicious food products. And in the end, or at the beginning, these are moments filled with smiles, creativity, and a relaxed atmosphere where everyone had fun, made new connections, and enjoyed their time together. By involving everyone in the process, we demonstrate that innovation truly thrives through collaboration, where every voice matters. Let's co-create and innovate together.
So, what did you learn from this? Basically, one word came out very clearly was co-creation. Yeah. Suppose a company is designing a car, yeah, or designing any equipment for the user, and they never use that equipment. Suppose a car, take it for example, Bajaj is developing auto rickshaw, yeah, and they are not the one who are going to use the auto rickshaw, yeah. That's why I just moved from car to auto rickshaw. They designed auto rickshaw, made an equipment, and sold it to those guys who are going to really operate it, or consumer who are going to sit in it, yeah. So, will that model be the best one, or you say, oh, they should have given this, they should have done this, they should have done this. You have seen all those type of question, right? So, to avoid that problem, if you do co-creation, that means to know what they think should be the best one, that is developing by design or design by using the end user into it, right. That is what is called co-creation, is not to develop just any product. You mentioned about vegan product, yeah. So, everywhere fish vegan product is not only related to the fish fillet, yeah. The fish paste is made, pate is made, and what type of product they want to have, what type of their choices are, nutrition and all, what is there inside is another one, right. So, co-creation, that means co-creating things with industry, and all the innovation without co-creation does not end up in commercial businesses, yeah. That is one of the most limiting factor. You are designing a system which is in your opinion is the best one, and no doubt it will be the best one in your opinion, but when it goes to the user, you can't use it. You can see numerous buildings are made, numerous infrastructure is made, numerous airports are proposed without knowing what consumers want and who will be coming in, who will be the user, yeah. So, it whole of the process, lot of money goes wasted. So, co-creation becomes very, very important exercise. Before launching into what type of vegan product we want, we see what people they want to have an alternative for. If suppose you are looking for all vegan fish product, is that vegan fish product as a steaks or as a fillet, or just those products which are used as a spread, like as a morning breakfast. They want to eat a healthy fish product, but morning they do not want to have a fish and chips, they want to have a bread spread. So, based on that product is decided, and then to see what are the things what they look into it. Alternative fish smell they are looking for, or fish like ingredients they are looking for, its nutritive value they are looking for, or better spreadability, you know, all those requirements are there, and based on their products are developed, and then it is tested, and then to find what where the fault lines are and what improvements are required, then it is created. So, once you have a concept, yes, I can make vegan fish like product, good, then how do you create it, yeah. And in order to instigate the interest, or in order to teach people how to follow that procedure, one thing is called living labs. How many of you have heard this word? This is very, very useful, like this type of video, yeah. The purpose of this particular video was, whenever the co-creation activities was carried out, this was recorded for educational purposes to show you guys how it works, yeah. The same way when you are making a product, if you have a video, like everybody makes reels on YouTube channels, yeah, how to make biryani, how to make idli, vada, different recipes, yeah. So, this is one form of living lab, yeah. But same way, this is the ingredient, this is the way mix it, you saw there 2 videos, that is one sort of living lab, yeah. That is for educational purposes. Another one is where you bring in the people, like CSIR and different institutions, they do open days, where the kids comes in to see how things are working, how food is processed, how food is dried, all those things comes a part of living lab, and that is all is reflected towards the social responsibility of science. Any school kid comes in, oh, that's a waste of time, I wasted one day of my research activity. Like here, those guys who are helping you, they are also doing the PhD, they have their day jobs. they are involved in this one. One way it can be seen that their precious time is wasted for 7-8 days of 2 instructor time is gone, but that is also a social aspect of it. Yeah. So that's what I meant by saying living lab. So you also have a social responsibility. So next time any school children are coming in, be actively involved in the process, because that is also the part of education system. Yeah. It is not a researcher, scientist is involved in undergraduate graduation teaching, but it is having a much larger responsibility. They are putting a lot of time and effort to make people educate. Education becomes an important part, and how to educate, that also is another set of questions, right. So basically remember one thing about co-creation, yeah, co-creation, involvement of different stakeholders, and how you get engaged with different activity. So you all agree majority of the stuff stops here. Yeah, you started your PhD, you want to find something, discoveries are forget about it. Majority of the research is not carried out to find an answer. Yeah, research is done straight away. Oh, I have done this experiment, I am waiting for my paper to be published. Yeah, or I am waiting for my patent to be filed. Yeah, or IP is intellectual property rights. Yeah. And one thing is important is discoveries. That means certain experiments are done only to find the answers. Yeah, you know the process I mentioned about. If you look into the literature, have you any paper if you come across to show how we get a fish protein without having alkaline extraction? Yeah, just you read the paper. Oh, alkali, add an alkali, get the protein. Yeah, but if you try other things, yeah, it may happen, it may work, it may not work. Remember Thomas Edison, what he said when he was trying to make a bulb with different combinations, he failed 1000 times. Yeah, so again he started trying. So his colleague said, you are still trying, you failed 1000 times. He said, no, I did not fail 1000 times, I know 1000 ways it won't work. Yeah, so there is nothing as good result or a bad result. Oh, my experimental result is not good. Not good means experiment is not done properly, right. That is what is considered as a not good experiment. Negative results are also results. Yeah, thing didn't work, that means hypothesis is rejected. Yeah, you think if you heat milk, you will get better quality protein. It didn't happen. So that is also a result. Yeah, it is not always positive things are published. Everything is publishable, right. Now this is what to do with discoveries, publication, patents. I know majority of you won't agree, no, I have to do the experiment, I have to publish it. Yeah, even though they published a paper which they don't understand what they were doing in it. Yeah, so that means whatever experiment they publish, they should be remembering it 5 years, 10 years, 20 years down the road. That means it was done with a clear intent. Yeah, lot of time, oh, I did this paper in my first year, so I don't know what was written in the paper. That means that time it was done not with the interest. Yeah, and what was the taking out of it? Remember, any work starts. Yeah, this is the trunk. Yeah, and this is the end point, start point, end point of a project or a PhD thesis. Yeah, so while doing that experiment, you get lot of different questions comes in a research. Yeah, and then if you just try to find answers related to that, this is what will give you fruits. Remember, trunk never bears a fruit, it always comes from the branch. Your task is to valorize the wastewater by using microalgae. If you don't like it, I will change the example anyway. Yeah, if you have to valorize the wastewater by using microalgae, in doing so you realize that the microalgae, instead of reducing carbon, nitrogen or inorganic nutrient, it is taking certain heavy metals out of it. Yeah, and accumulating into it at a specific point. And then you say, oh, no, that was not my interest, my interest is only on BOD and COD, right. And then that can yield into a new area. That means you are able to trap all the heavy metal into one place. Yeah. So these are the findings. So you start with one objective, and try to follow that, and when you are doing all those experiments, keep your eyes and ears open, and then to see what is happening, and from there ask those questions, why this is happening, yeah, try to find an answer in a literature, or else try to do some bit of investigation and then come back to the track. It is something like when you walk in a shopping mall, your target is to go and buy a pair of jeans, and you end up buying everything else, yeah, just because there was offer, this was this benefit and other things. But when it comes to research activity, our focus is I just need to finish this experiment, yeah. So, the way we are in our own day-to-day life, same way we are into these activities, yeah. So, if suppose you started, you ended a research and you got a process developed, yeah, that is basically a patent, for instance. Then if you study the product, for example, somebody is extracting a plant protein, they got the best plant protein, and if they compare that plant protein with existing proteins, looking into the properties, looking in the application, that all can go for publication, that is studying the solution, yeah. And when you are extracting those protein, you have done number of different trials and errors, different experiment, tried alkali, tried this alkali acid and different permutation combination, and you got to the solution. Then go back, and each and every trial you did, you just investigate those, that is studying the problem or studying the solution can be easy publications, yeah. An actual solution can be IP or a discovery or intellectual property. So, everything can be done. It is not my work is commercial, I can't publish it. That is not true, that is an excuse, yeah. Obviously, why you will be publishing a specific conditions, yeah, but studying the impact of temperature on coagulation, that is a study what creates the knowledge, yeah. So, it is not that I only, if you focus only on output driven, then you will never be able to achieve those things. If you remember that shlok, keep doing the job, don't worry about the outcome, or any work done in anticipation of an outcome is not a work, yeah. So, once you have research output, next one comes research transfer, that is engagement with the end user, yeah. Once you have created a process, created a technology, then you have to engage with the end user. End user can be your consumer, customer, business to business, depending upon what are the stakeholders. So, what are the main research outcome of any project or any activity? You develop new product or improved product or processes, yeah. When we use new technology, we are improving the processes, yeah. You create a new service, software development or other one, or you make entirely new process of doing things. And then how do you establish the impact of that work? How do you quantify? You spent €1 million to carry out the research project for 4 years. What was the output? We got 3 papers. That is also good. You have created a knowledge there, yeah. Apart from your own benefit, somebody got employed for 4 years, somebody got a promotion, somebody got this. What are or what is the research impact? Value added improvement, economic benefit, social benefit or environmental benefit. All those benefit what funding agency, that is government, is looking for from the research, yeah. That is very important. Then you have national and international benefits. You understand how we can create carbon neutral environment, or take example of vaccine itself, yeah. When all the money was added into the vaccine research for COVID, what they looking for? Publication. Main was benefit, social benefit, yeah. So, everything which is added into the research is not or should not end up here itself. So, one is linear model, but more complex in real world, we all know that, yeah. Varies according to discipline, some are tangible, some are non-tangible. When you mentioned about qualitative and quantitative one, yeah. Historical research to understand how people decided, how a country emerged, that is qualitative one, yeah, or non-tangible one. Some places you have tangible, takes time, but there may be intermediate outcome on the way, yeah. You are developing a system, suppose you know all those moon mission and all those big rockets which were launched into Mars mission and different missions, it takes 6 years, 7 years, yeah. So, that is also research. They are not the one who are looking for publication. It takes time. Everybody knows it takes time, but that should not be taken as an advantage for the researchers. Yeah, researchers are not the one who are 9 o'clock coming on sitting on a computer like a bank account and goes in the evening. So, it is 24/7 activity. We have to keep thinking. Evidence, need to monitor and collect evidence at each and every stage. That means observation. Yeah, observation is the key. The person who discovered radium was discovering something else. If you see Marie Curie's biography, yeah, radium was accidental one, but only because of observation it was obtained. Yeah, same thing happened with the carbon. The last 2 years ago, the Nobel Prize was given for somebody who was having a pencil scratched onto the paper. Yeah, if you know about graphene, yeah, thin layer of carbon. What was the experiment? Rubbing the pencil or having a tape. Yeah, if you go and see last, it was from Manchester in the UK, the Nobel Prize. Who received the Nobel Prize? It was not making a rocket or so. It was mainly experiment was a pencil, lead pencil, scratched on a paper and with the sellotape to create a graphene layer. Yeah. So that's also there. That means somebody was sitting on a table and the same thing got particles. Yeah. So all those things were based on just observation. And we all are in hurry. So we call hurry makes worry. So that's to understand, does your research makes an impact? Yeah. It is self-propelled impact. Oh, I am doing this, this will solve this problem, that problem. No, just talk very, very specific one. Ask any question. Oh, I am working on this one because this will be more sustainable for the environment. That is non-tangible long-term impact. Yeah. But what is the immediate impact what you are solving? Yeah. That is immediate problem what you are sorting it out. Now, public funded research, this is from Cunningham and there, this is 3 helix one. Who are involved? Government is involved, university is involved and industry is involved in these activities. Scientist who takes a role of publicly funded principal investigator, that the person who is dealing with the project, are the linchpin of the knowledge transformation through articulation of research programs, shaping of the research avenues, bridging the academia and industry. That means the person who is running the project is a principal investigator. He is having 1 PhD or 2 PhD working on it, or there is another postdoc or research employees are working on it. But his main thing is whatever different people are doing activity, how to take that information and transform into real activities. So in most of the cases after PhD, how many of you have heard this word postdoc? Yeah, what does it mean? Postdoctoral fellowship. Yeah, if you read this word carefully, that is called, one thing is post-mortem. Yeah, but what happens? PhD does the research, postdoc writes the paper. That's completely wrong structure. Yeah, so whatever research is done to see what you got and what further investigations are required. Where the question is, oh, you have done this. I was not having some good analysis, get SCM images, get this one, we can publish a paper. Yeah, that's the wrong way of doing it. Whatever is being done, to look into it, what extra analysis will add value to that work, or what new area of experiments can be carried out. And then that's called post-mortem, that is analyzing the study because one has already completed that particular task, PhD is finished and then he moved to another one, right. So that is very, very important when it comes to PI. That's why I just read a quote from this particular paper. Other one, PIs at the micro foundation level are the nexus or interaction between triple helix actor that influence drive research agenda. Now it's a quadri helix model there, and the 4th element is also added into it, but I don't want to go too deeper into the philosophy of research and the science. There are number of different journals who are only focusing on these type of things. Yeah, that means if research is done or research is carried out, your responsibility, what your task is to carry out the research in a given project, get the data, publish it or to find an answer to a question, right? Postdoctoral question is to see whatever is done, whether you should publish it or you should protect IP, yeah. So that's you all know, I am not going to go in details of it. So in addition to scientific excellence, these are very, very important. Any research what you are doing, shaping your research priorities. What should be the priority area of research? Shaping the ethos of research integrity is very, very important. Is not just to do it, do the minor adjustment here and there and publish it, yeah. Or I am talking about all those not illegal, well, whatever activity you want to call it, forging the data, creating the data, yeah, that is against the integrity, yeah. That is called slander, theft. That should not be done. Let it be wrong, yeah. Redo it, let it take time, but modification of any such thing is no in any case, yeah, because that's is something like crime. If you are working in a bank, stealing 1,000 euros is the same thing in a research. That is also called thief, yeah. Forging a data is equal to a crime, yeah. So that is taken very, very seriously. Think of you are doing research, that's okay, nobody is crying and all. Suppose if the medical research is there, somebody forged the data and published the study, and somebody adopted that particular formulation and killed 1,000 people, yeah. That's why it is a crime, whether it's any research, whether it's a food research, medical research or any research, all research comes from the same money, yeah. So that's why this is really important. So when you are doing work, make sure these are there. You are shaping up research priorities, but whatever work you are doing, how that can be instigated into further work. Ethos, that is integrity. Fostering interdisciplinary activities, transdisciplinary or multidisciplinary. That means when you are talking about, again, microalgae is biologist, wastewater, environmental engineers, designing the system, process engineers, you need different streams, knowledge of different streams. That is why sometimes I call it as a food science is a common science, which is not so common in common people, yeah. So you need to have a knowledge of all the discipline. You can't be expert of each and every knowledge. There is no harm in seeking opinion. And second thing comes in, oh, why should I take an opinion from this this person? He is only first year PhD. I am senior PhD. Why should I ask this person? He is just doing the first year BTech, yeah. Because egos comes in between. Whether the idea is good or bad, it depends upon who is saying it, yeah. Same thing if your boss or your line manager is telling you something, you just readily accept it without arguing, yeah. That is another bad thing. You either get convinced or convince. There is nothing in between, yeah. Either you convince somebody to do something or you get convinced, yeah. So there's nothing in between. So you should know what is your current strategy. Prioritize areas of possible exploitation for your own research expertise. So these are pretty much the same, and it's coming into how we can achieve scientific excellence. So coming back to the same diagram which we saw the other day, right. This is the basic research, most comfortable one. Go in any time in a lab, do the experiment in beaker and test tube, that's fine, yeah. Even sometimes if you think about agriculture experiments, people who are working on agronomy, forestry, they grow a crop taking 1 year data, and all of a sudden heavy rain, flood, tsunami, gone, yeah. So that's also another issues are there. So whatever research we are doing, to see how we can transform into a commercial activity. So if you want to see more details about each and every level, what does it mean, what is included, what is not included, that is you have to go on a website of NASA, and that's you will see TRL levels, technology readiness level, NASA, and you will find all those stuff, yeah. Okay. So obviously this is quite complicated, we have already covered that. So you understand what does this arrow indicates, yeah. basic research, when it goes to innovation, yeah, innovation transformed into commercial research, yeah, and from there other problem comes in and then to modify it, yeah. So that's why this is the area which mint maximum amount of revenue, maximum amount of money. This is input, money goes into this one, and from here money comes out, yeah. So that's why everything has to go to the next level. Now, what happens? You'll see this is one of those. If you go into this, that is Bioeconomy Research Center, yeah, and I am one of those PI of this big multi-million euro center. This is biorefineries.com. If you go into this, what is the engagement model? Because majority of the work is related to industry and transferring the project to industry. So if you see any new project what is started, principal investigator, industry, we discuss what is required, and EOI. What is EOI stands for? Expression of interest, yeah. Industry says we have, this is the problem. We have a researcher, he says we can solve the problem by doing A, B and C, a sort of co-creation activity, and then project is developed, very short project proposal is developed with industry, we get a feedback, reviewed, and then contract signed. So this is the model where industry is engaging directly with the researcher, yeah. It is not that funding call is out there, you write a proposal, you submit it, yeah. So that means applications are developed based on industry requirement. Lot of these things are also happening in different institutions in the country. Industry comes in, wanted to meet a researcher, I have this problem, concerned researcher, oh we can solve this problem by doing A, B and C, yeah, and then they develop a proposal, contract signed and works start, yeah. So that's one. Now, what happens in case suppose what I mean by TP is targeted project, yeah. That means it's very simple target project. I'll just open it. When you start a project, what do you get? You can put your PhD project also here, right? Yeah. Because the whole purpose was to show how we are engaging with the industry and how do we make innovative model. You have any project, even a PhD project, what do you get? Data, yeah. And what with data, what you do is whosoever is involved in it, if it is industry project, discuss each and every data with the concerned PI, PhD, postdoc or other stakeholders involved in it, yeah. Then to see whether you can protect IP or is just the knowledge which has been created. That is the point. You should see whether you should go for publication or to engage with TTO. What is TTO? Technology Transfer Office, yeah. That is, some places different departments are there, IP departments are there, business development or extension department, you know, they are named differently. I am just talking about the model, what is there with us, what are the departments here, and then IP is protected, and once patent is granted, and in our place you cannot have a patent filed unless until there is a buyer. It's like, you know, you see that in China and other places, oh I have 75 patent, 85 patent, but how many business started? No. In Europe you can't do that. Patent is only filed, we call it IDF, Invention Disclosure Form, yeah. So when that gives a number, because filing a patent costs very heavily to the exchequer. Government has to put huge amount of money to file a patent, yeah. So we only file a patent at European level, national level, or sorry, European level or international level. One, there is a person who is buying it, yeah, who is interested in to carry out the pilot scale activities. Then the licensing agreement is done, yeah. And almost every patent has led to one business, and those companies are made and sold for a couple of millions and billions to other bigger companies, right. It is not the patent is there, who is using it? Nobody is using it, yeah. So that is why the engagement model works. Do you think any improvement is required in such model? There is always chance of improvement. Yeah. So, this is one of those engagement model. Moving forward, I will give you this example again, coming back to the company marine one. Yeah. You have already seen these ones. Yeah. Now, this is all when aquaculture was done. These are some of the people went into the sea to see where when the seaweed is grown, you know, with those ropes. Yeah, it is not at the shore. We have to go deep in to get at least 500 to a kilometer in to see those ropes harvested, and all those things what was done in the lab, and this is all done in pilot scale. Yeah, I can't identify those guys. And then you have, these are the guys who were developing hydrodynamic cavitator based on the requirement. Yeah, you saw the machine previously, and then all those operations, and then pilot scale, very same man who is here, and this is coming out of a spray dryer, 800 liter per hour capacity. Yeah, when product is made, 800 liter per hour capacity is a huge one. Yeah, that is the spray dryer which obtaining a product. And then this is Anuga. It's not the name of a person. It's just the biggest food ingredients event, happens once in 2 years or once in a year in Geneva. Yeah, where all the companies from the global market they comes in, and then there are investors and the people who are launching the product. It's the same company as mentioned about Nutramara. Yeah. So, all these activities, it was not done in one day, right? It is not done in 1 year. This took around 5 to 6 years. Yeah, and work has not been stopped, it's still going on. Yeah, now to look into different applications. So, you have already seen this. This was started with. Yeah, and you have seen all the biorefinery processes. Whatever I was covering, all the examples were associated with fucoidin, algal fiber, carotenoids, and other ingredients. Yeah, and then what is out there in the market. Yeah. So, any questions so far? Now, I will quickly run through these few strategic documents before we go on to the next one. Is all to do what are the innovations, and all these documents are freely available, though they are quite old, not very old, but still they hold the value. Some places you do not know what direction you have to go, what is the innovation route you should be taking. Mission oriented research and innovation in the EU, a problem solving approach for fuel innovation led growth. Very nice document which shows how you go mission oriented approach, what should be the approach, that is also very important, right. Again same thing, future scenario for research innovation policies, and why European document are some way better. I am not promoting European document compared to other places, because this involves multiple countries. Yeah, any policy document made in India is exclusively for Indian subcontinent, right. If it is done in US, it is for exclusively for US. European documents are made by combined activity of 28 different countries. Every country is having its own primary requirements, right. So, it takes lot of time, lot of brains have gone in to make a document. So, everything comes out in a very plain language, yeah, so that everything is understandable. And you know all about United Nations Sustainability Developmental Goals. Yeah. So, what we will do is when we come back, we will have a quick recap, and then we will just go with pretty much the last one about the publication strategy, and we will quickly run through about IP and how do we publish it and how you can publish good papers out of it. Yeah.